Thank you, everybody, for coming to this webinar. Um, this webinar is born from real-life experience. So the motivation behind it was no time, no budget, no people, right? And it came from two migrations in which I've been involved. One is still ongoing, but we're basically near the end of it. Been quite successful, actually, but there were challenges. There were a lot of challenges. And in every case, we had two migrations from legacy platforms. Coincidentally, both of them were Fortran based. It's very high performance. Fortran, as we know, it is a high performance language, so we had a really tight tolerance in terms of performance expectations. And so the question was, um, will we make it in the migration? And as anyone involved in this business knows, for enterprise, that's probably, I think, one of the riskiest activities in which one can engage. And the system image service on JuliaHub made a huge difference. It literally saved the project in both cases. And this is not to take anything away from Julia language itself or anything like that, but it was more about organization limitations and simply the abundance or lack thereof of manpower or time or budget. So the purpose of this call is to cover the real life design considerations for cloud performance. And I need to give a quick JuliaHub overview so you have some idea of what I'm talking about. I don't know the audience's familiarity with the platform. The platform itself becomes fairly self-evident for why you use it when you start working in JuliaHub in a cloud environment, but I'll give a quick overview. The consideration in mind for this whole session is a migration, and we will touch on Julia packages and package compiler.jl. Why? Just so you know what's going on behind the scenes. You don't need to know the details of how these things work. Hopefully you don't have to touch them if you're a busy person in an enterprise environment with other things to do, but it will really help ground your understanding of what's going on behind the scenes and why you have to make certain decisions. Because the objective here is to go over these three anti-patterns to avoid and show a quick demo so that you can take advantage of the system image service on JuliaHub and have extremely high performance without investing an inordinate amount of time and optimizations, or what I like to call artisanal code, having very carefully crafted code. Okay, is there a solution? Can we let the compiler do the work for us, right? That's really what we're trying to do. We're trying to push the workload to the technology rather than developer and apply the organization. And then a conclusion. So quick on JuliaHub. What is it? Enterprise computing platform. JuliaHub, in summary, I could go through all these things. We don't have tons of time and I got a lot to cover, but basically it allows you to use the Julia language in a stack. Okay, where we're talking about here is you have multiple layers in your software application stack. I'm thinking really about the compute layer. So like I said, in both migrations, which I was running, we had a Fortran compute layer. That's a high ask. It was a good code. It was good, but it was Fortran. It was custom. It was definitely not cloud. It didn't have all the advantages that Julia language had in terms of portability, right, across architecture. So there was no LLVM, obviously. So we create JuliaHub to allow that flexibility, and it's extremely effective. And so, yes, JuliaHub provides you the ability to run jobs and apps at scale, so you can provision resources for running what we call a job with an application. An application is simply just a computer, okay, with resources being memory, CPUs, GPUs, etc. And you essentially give it a Docker image or a GitHub repo, which then becomes a Docker image, and that instantiates a compute instance with those resources. And you can log it, you can observe it, you can have events fire off in it. It's very nice. We also have a data storage system and a way to deal with the data. So if you have data, you need data, low latency data on the platform itself, we have that as well. We call it the data set system. Relevant to this, actually, it is obviously docs, but we also have something called package registry. That is quite relevant later on. We will talk about the package registry briefly here, but it will pop up again towards the end. And IDE notebooks, and that's a nice to have. That's not the focus here, but it is quite nice. So the package ecosystem right now, this is covering open source packages, okay? My presumption is that you're going to be an enterprise company. At some point, you're going to have proprietary packages. And that's where, if we go to the previous slide, we have this package registry. That package registry will point to your private server with your code on it, right? So for example, if I'm using a repo that essentially is going to be my pre-compilation target, I need this package ecosystem in the registry on JuliaHub to enable me to do that. Because the concept, and we're going to get into this later, of pre-compilation, essentially package compiler, revolves around packages. So Julia revolves around the package idea, and JuliaHub is central with the package ecosystem. So out of the box, you get all the great, 9,000 plus open source packages in the official registry, but you have the ability to create your own. And that's when we talk about the package manager and private registry. So now you have the ability to create your own private registry. Essential. This is a very big feature. It's a huge feature, in my opinion, because not only does it give you complete versioning control of your dependencies, right? You're no longer drawing. I mean, you can clone it. I mean, you could do whatever you want with your dependencies. You can have open source dependencies, but if you want closed source dependencies, you can have a hybrid. I mean, this is what a lot of people do, right? You have your hybrid dependencies. So for your private dependencies, especially the ones where, I'm thinking both of my migrations were OLAP related, analytics, warming up queries, right? That should absolutely not be a public repo. It needs to be a private one. And that is an example of something that you would put in your private registry and use the package manager to access it. So this is a integral feature. It is part of the design pattern. And if you look onto the right here, you look at this, right? Come on, wait that mouse. You see, like, you have your compute here, right? It's a hybrid. So you have your public repos and you have your private ones. And that's the idea. You get the best of both worlds. Some things indeed need to be public, and you want to benefit from the open source community. You want to benefit from that resource, but there are things whether it's related to IP or operational security or proprietary, customer client data, you certainly want to keep those private. So you have the ability to seamlessly do both, and because you have a private registry, which is essentially a phone book, it just associates a dependency name with the location of the actual, in this case, GitForge. That's all it is. But that's easy to do out of the box through an admin. An administrator would configure this for you. The cloud station alludes to what I talked to before in passing about applications. Applications are computers, essentially. And when it talks about turning your laptop into a supercomputer, what that's saying is that whoever you are in the persona spectrum, whether you're a developer, analyst, um, I'll give a more specific examples. Like in enterprise, I see core developers, and then I'll see, say, analysts who write custom code for a platform developed by a core developer, right? So you may have different resource needs for those jobs, and in which case you can easily configure them. You can do this over the API through the command line, or you can use through the nice UI. And it's observable. You can have all sorts of timers. You can constrain by cost or by time. It's works very well with our workflow. In terms of security, this does come up, SOC 2 compliance out of the box. We have, for very, for like pharma or aviation or very secure, the extremely high security tier people, we have the SDLC lifecycle. So for any sort of validation, qualification, if you're in pharma, you know what I'm talking about. But even for people in aviation, et cetera, who need that extra layer of procedural security when it comes to SDLC, we have that at least at the very least, it's documentation and certification where required. Which mentions, by the way, this FDA 21 CFR Part 11. In terms of network security, we have the canonical provisions, which is TLS, DDoS, VPC options, which are usually required by many of our clients, and the usual encryption and uptime availability and SSO. Oh, and with respect to application users, we basically piggyback off of your SSO. So we don't introduce our own user table. We just piggyback off whatever you have. So that's nice for you. Your admin will essentially dictate, your own SSO admin will dictate the groups and the users of the application, which in this case is considered your compute layer. Projects we're not going to touch, but they are a feature. They're just a way to encapsulate data and code. If you want them, they're there. They're great. They have a lot of nice, handy integrations. their main purpose of a project is it's an alternative to a Git repo. Okay, so if you have different personas who are touching a code repo, but some of them, may benefit from not having to work directly with a Git forge, use a project. There's some other cases too where the project has some, and this is developing too in the roadmap, has some really nice integrations with JuliaHub itself. So projects are great, but they're really meant for a collaboration tool, or if you need a validated proof of record, because the projects essentially will enable you to track changes, just like you would again on a Git forge, but in a handy user experience. This is the IDE that's built into the platform, essentially VS Code, but tuned for Julia. A time capsule is really neat. This allows you to run old bash jobs with everything the same, right? Same machine image, right? So the same CPU architecture, everything. This is really for very, very, like I said, for our more regulatory minded clients, this is a very nice feature to have. So I'm looking at the typical development scenario, which is we're migrating a legacy application. In my case, both cases, my recent migrations were Fortran based. So again, we had a very tight tolerance for performance. As we know, Fortran's, well, when well done, is quite fast. You have a diverse team of people, right? You have analysts who write, as you could say, call like higher level code. You have, in some cases, people on different stacks. You have maybe someone on a Java stack, someone on a C# stack, someone who's a C++ developer, all working together at different parts of the stack of the application. And of course, you never have enough time, money, or people. And within the organization itself, now JuliaHub, as we came as a consultancy, we have to help them succeed, and there's a bit of education. The question is, how much time do they have for us to upskill them? And should we really upskill everyone, or should we try to be as efficient as possible? And the answer is obvious. So what I focus on is saying, what are the minimal bare essential patterns we need to impart on our client so that he has success in meeting his design tolerances or his expectations, performance from such a high bar as Fortran. And so what's your definition of performance? And I thought very deeply about this one, and I said, well, if you had a time, talent, and money, it's artisanal code. That's Donald Knuth, for those who are familiar. Wrote the best computer science books ever, quite good. But that's a nice to have. I put to put it mildly. And reality, it's caching. So when people talk about performance, and I hear it, I think caching, right? Like I need to have something warm to run. I don't want to be overthinking this because there's just so much to do. And again, resources are constrained. And with respect to performance, there are things we won't discuss today, but they're very relevant for Julia in general: type instability, allocations, profiling your application or your compute, and parallel processing. All of these merit individually multiple webinars for each one of these topics. If you want to go into more thorough diagnostics of your Julia code itself at a deeper level, these are 4 broad categories to consider straight away. But we will not discuss them today. So with the performance is caching mindset and approach, something that will enable us to not only cache as many costly operations as possible, but also be maintainable and work across teams. And that, practically speaking, in the field means ops and dev, right? So the people who keep the infrastructure up and running, keep it compliant, and the people who are providing new releases. And that motivates the design of our system image service, which we'll get to in a moment. So for caching in JuliaHub, the motivation for how our system image service, which is basically our caching system, works, is from the Julia language itself. There's an expression called time to first plot. It is said that at times we call it TTFP, because it's a JIT compiler runtime, and in the compiler architecture, consequently, when you first run your Julia code, people will say, well, it's slow. You'll hear this in the Julia world. It's not slow. It's just how it's designed. It will not be slow the second time you run it, I assure you. But when you are warming up an enterprise compute layer, this is a consideration. for sure, you do not want to go in cold. So the solution is to precompile the costly stuff. Yeah. So what's the correct pattern? And it revolves around a specific package. When people talk about precompilation and the system image service on the other end of the JuliaHub itself, that revolves around the package compiler.jl package. I don't know if any of you have familiarity with that, but that is that's the governing principles for how we deal with precompilation and caching comes from package compiler.jl. So if you want to go deeper into that, you can explore that, but that does anchor what we do. So we precompile packages, we don't just precompile everything. You can, but we don't on JuliaHub. You can using this package compiler on your own repo or on your own locally. But if you're doing it to JuliaHub, that's not quite how it works. So to make JuliaHub manageable, to have the selectors on the back end work the way we want them to, we require you to work in terms of packages. And the idea is that packages, this is like the essence of the presentation. Like this slide is sufficient, but I want to obviously more talk about, but this is very important. Everything that matters needs to be in a package. Everything that changes needs to be in a package. Anything that's being shared or collaboratively developed needs to be in a package. Obviously, this was inspired by our distributed open source origin in terms of how things are developed. But people use packages standalone with some sort of entry point, or they obviously are nested as dependencies of other packages. That's how the distinction, say, between the manifest and the project tunnel. But this sounds, if you're a Julia user, you're just like, obviously I know all this. Right. Well, okay. But if you've been programming Java for 15 years, right? If you think in terms of DLLs, if you think in terms of if you've been a C or I mean, God, Visual Basic, maybe even Fortran developer, like this is it's a slightly different way of approaching the problem. And we couple that with, this JIT architecture. How do we do this need to basically warm things up? Now you see the need, we say, hold on, I can't just naively map my Java application or my C++ code or whatever to Julia, or try to get out of this Fortran thing and just map it naively to Julia. I have to think in terms of packages because I need to have a quick I have tight tolerances on performance, it's cloud-based, et cetera, et cetera. So you need to make sure that when you design your application, things that matter, things that change, and things that can be shared, and most importantly, as we'll see, things that are costly you should try to push them into a package. Like I said, not using packages is the first anti-pattern I've encountered, but it is possible using a package compiler.jl. You can just generate an app or C library, but that's not how our Sysimage service works. That's a whole different discussion I will go into. So, I've gone through the motivation of how caching works. It's the origin is through the package compiler package. I've seen workflows work on the system as a service where people have batch jobs, right? So we push the costly operation into a package, I have that in quotes, or whatever you call that, either invoking dependencies, writing some functions, right? Now, if you go to the package compiler.jl documentation, it goes into this extensively. You can put functions there. And a classic one that I've seen multiple times is warming up data structures that will be used in a subsequent query. So examples like a giant dit, right? It's like something slow, a bunch of other dependencies, a bunch of nested, it's just slow. And to give you some idea of what I've seen in the field, to do this cold, 15 to 20 minutes. Cached is 6 to 13 seconds. Okay, like that's the scale of improvement I've seen. I'm not putting it in the slide because I don't want people calling me out and saying whatever, but I have seen that scale of improvement. It's significant, right? It depends on a million different variables, but I've seen it gone from over 10 plus minutes to under 30 seconds. That I'm comfortable. If I hear that as an improvement, I believe it, right? I say, yeah, that's quite plausible. The cache selector, and this is important for you to know as well, and this is also why you have to use packages. Because the cache selector within JuliaHub itself, that's selecting which system image to load up, uses the manifest. So guess what? If it's not in a package, you don't get it, right? It's just it's just not going to know. So yeah, main.jl is got all this, warm query, you're warming up all your queries in main.jl. No, it needs to be in a dependency, and it needs to be a dependency that sits in your manifest, and then it will work as you expect it to. Yeah, it serves as the packages. So I wrote a little demo, I mean, just to illustrate the workflow and put some, practicality here. I used two packages for a simple demo script, um, just to illustrate the two dependencies being used. Now, the package being used here is JuliaHub.jl. I'm using the REPL today just because I like the workflow. It's very evocative, like it's just nice. But you can also do this in UI, and I'll show that too. The package I'm loading is the primes.jl package. All I'm doing is counting the number of primes here, okay, up to some integer. And the question is does pre-compilation using the Sysimage service pay off? Because to load, in this specific case, I'm not pre-compiling a given compute. I'm pre-compiling loading all the dependencies. So the alternative between having the Sysimage service off or on is the pre-compilation of these two packages. I just left them. In fact, the JuliaHub.jl does not necessarily need to be in there. I just left it in there because I'm using the REPL as well. JuliaHub.jl is a package that allows you to talk to JuliaHub directly from the REPL. Nice. The alternative is you would have to make a post or GET request, right? But this, you don't have to do that. It's really nice. So I made, my dummy script fastcompute.jl that just invokes this function. And so just to reiterate here, with the Sysimage service active, the things that are going to be pre-compiled are all the dependencies from both primes.jl and JuliaHub, primes.jl and JuliaHub.jl in the manifest toml. So if you look at the project toml, you say, well, they're just two packages. What's the big deal? No, it looks at the leaf nodes. Okay. So all of them. And that's again why there's such a huge payoff, especially if you start pushing functions into if you create a new custom package, you put it in your private registry on your cloud, and you start pre-compiling that, you start loading that with a lot of computations that are slow and costly. This will be picked up, that will be pre-compiled. And so when you launch your server, right, and you run that query, it will be lightning fast. Things that are not touched with the pre-compiled Sysimage service is fastcompute.jl. You recall that's look at my directory, right? I'm using this as like my pseudo project. I have manifest, project, and a fastcompute.jl. This thing's untouched. So when I activate the Sysimage service on via the REPL or through the UI, this code here is not going to be precompiled, whether I specify to do so or not. Anti-pattern 2 is relevant app code not in a package. That's not using packages. I actually already said all this. So again, if it's not in a package, the selector will still use whatever matches the manifest toml, and you will not get the performance boost you anticipated. It's going to go through the JIT. Last thing, and this is kind of a gotcha, but I've seen it happen and I've done it myself, so I'm going to tell you, is carelessness with Julia versions. Julia is really good about warning you about that, but sometimes these are subtle things, right? Like in the field, you may see subtle changes, and there's always a little bit of noise in the network. And as we all know, recreating environments in prod is basically impossible, which is why we try to observe as much as we can to avoid having to recreate that environment. But yeah, if you toggle or if you work across Julia versions, be mindful that goes into the manifest. So if even if you say, oh, well, I'm going to load my project with a different version, I do some work here, especially if you're going across personas, just be mindful of the version, because that will trigger, that is part of your manifest, and that will select possibly a cache that you didn't want to run. And so it may omit something that you didn't want included. So this is counting up the primes to an example. Uses primes.jl and JuliaHub.jl packages. Neither one's big, but it still takes some time to compile at runtime. And it runs roughly 3 times faster when I do it. Now, this is a very small, trivial example, but I just wanted to illustrate the workflow and that it actually does make it faster. In real life, it is, by my experience, I'm not gonna, submit a white paper on this, but my experience has been it's an enormous difference. I've seen load times cut from 15, 20, 30 minutes to sub 30 seconds, sub 10 seconds, depending on there are a bunch of qualifiers there. But it's huge, simply huge. And in my case, especially with the OLAP focus on both migrations, it was decisive in making the application work as the client needed it to, especially coming from such a tough place as Fortran, which is really, really very fast. So 15 minutes to seconds. So this is what it looks like, a simple job run, what I just showed you, counting the primes, around 40 seconds. I mean, it depends, there's some variance here, but let's say 42 seconds in this case. And you can even see, right, it's checking if this image is available, activates the project. No, it doesn't find one. Okay, it runs. And so it's about, 42 seconds. With the Sysimage, it's 14. This doesn't scale the way you want because there's like a sunk cost of standing up an EC2, and right? So I'm not amortizing that over a bunch of dependencies. But if I had, say, a fatter manifest with a 10-minute load time, you would see a huge significance. I just didn't want to clutter my demo with that. But test it out yourself, get some big, costly dependencies, very sophisticated ones that you need to load, and you'll find that, yeah, you know what? Your time to first plot problem is solved with the Sysimage service. And because we have private registries, you can not only put your pre-compile your packages, but you can start using the private registry in JuliaHub, put code, and in addition to packages that you want to keep proprietary, but also add function calls that you want to precompile to do what I said, which is warm up your queries and get those tight tolerances that you want for a successful migration. Because I can tell you, in both cases, this was decisive. This is image service. That's why I'm here. That's what I'm talking about. But I need people to go into the engagement or we're using this to use packages correctly. And that way, they'll integrate very nicely. And you'll be relatively low stress comparatively. I'm not gonna say it's not. No, migrations are stressful, but it will be successful, or much more likely to be successful. Let's qualify that. Here's the code. It's a script, guys. It's not even code. I didn't even bother including a repo because come on. It's like not even really, it's like 2 lines. So it's using, invoking the things. I threw in this just to add a little more load to it using JuliaHub. In fact, the code doesn't use it, but whatever. And so all I'm doing is counting the number of primes up to 10 million. That's it. And I invoke it from the REPL using the JuliaHub package. I just check what's in there in that given project. It's just JuliaHub and primes. Okay, that's within Project Tunnel. To get in, I use a different instance. I'm using the internal server right now, but this is the syntax I use. Is JuliaHub.authenticate and JuliaHub.com. This is what you would likely use if you're on a special instance or you have some prefix, specific domain. You'll put that if it's whatever. Special company.juliahub.com, right? Or university of whatever.juliahub.com. You would put that in here, and then it would prompt open a browser. It would ask you to authenticate. You do that, and you're done. You could proceed using JuliaHub package, using the JuliaHub package to talk to your JuliaHub servers from the REPL. Very nice. And this is how I submit the job. So when you use a JuliaHub package to submit jobs, it's worth me explaining this. There's something called an app bundle. Let's start from the inside of the expression, right? I create something called an app bundle. What is that? It's kind of like building a project. I already have a TOML, so the project already exists. An app bundle is kind of like a JuliaHub thing. It creates a nice little handy tarball, so I can shoot that off to JuliaHub. It's a little technical. I don't want to go into there. But this is the syntax you're going to see. And this @dir, this macro, that refers to the root level of the project. So in my case, I'm already in the fast compute path. So it's just going to be @dir. But whatever path the root of your project sits, that's what you're going to put in this argument. So it might be a string that you have to compose or construct, but you would put that there. So that's the root path of the argument. This is the entry point, I like to call it, or the main.jl or your whatever insertion code. And this is the final one. Sysimage equals true. This is it, right? If I have that active or I don't, that literally determines whether or not I'm using Sysimages. Let's see here. So now I'm going to do the demo. And when I jump into the demo, actually, I can give a brief detour. Oops, sorry. I already ransomed. Just want to show the UI for a second, right? Like here's the home button for JuliaHub. You have your little carousel here of applications, my projects, my jobs. The applications, these are the things that I'm standing up. So if I click like add an application, that's where the GitForge goes. I have different types of servers for the GitForge. And so that's going to spin up an instance. So I'm sorry, that gives me the payload, so to speak. Like that GitForge is quote unquote like the payload for a Julia job. And then the jobs are here. I'm going to skip the rest of this. I'm not super concerned about that. I mean, registries are also important. This is where if we were to add a registry or construct a private registry, we would look for it and maintain it here. Just note that if you're building a private registry to host any sort of package that you make internally and you want to keep internal, private, and secure, the registry would have to be created by an admin, or you can ask us to do it. But that's just qualifier. So not every user has the right to create registries. This is jobs. This is very essential. You see there are 3 tabs here. There's like a mouse, come on. There's active jobs, completed jobs, and time capsules. So active jobs are jobs that are obviously running. My mouse is still going cooperative. Completed jobs, fairly intuitive. These are jobs that are completed. And they're time capsules, right? Which are instantiations that I could either, and oh, by the way, just note that I can actually just click and rerun a job. Because a job type is a batch job, I can just rerun it. If it's an interactive job, and so I can give an example of that, which is like, maybe like one of the web browsers or something, or excuse me, one of the notebooks, right? Rerunning that doesn't make too much sense. So it needs to be, excuse me, I'm sneezing. It needs to be of a batch type for this rerun button to appear and be meaningful. That being said, and I should mention this is an aside, this is why you have webinars. You can have a batch job that is interactive. What it means is you open up a port, and literally you add an argument to, your when you submit the job, you open a port, and you can actually have a server, like an Oxygen server, for example, with your own endpoints that would take API calls, right? And so, like, to be specific, like when I'm running that, when I've been running batch jobs with an interactive dimension to it, what happens is when you rerun them or when you warm them up, you go everywhere up to the server, right? So if you want to warm up the query, obviously you still want to push those expensive dependencies and any function calls into a package so it's executed. So when your web server is up and you're hitting the application side, everything is warm. So yeah, so this is the jobs page. So typically what you do is you hit this button, start a job, and there are different profiles of jobs. In this case, there's standard, which is what we're touching, but there's the Pumas. These are all custom, like Julia batch jobs or Julia related batch jobs for different products or kind of custom applications. We would only concern ourselves with this. And as you notice, you choose a machine type, you choose whether it's distributor or single, the time limit, and you can toggle that off if you want. And the advanced option is you would use a sysimage. This is how you would do it in the UI. Okay, so you would go through this interface. It's nice, it's convenient. I'm just going to run it through the REPL because that's what I do. But definitely feel free to use the UI here to start and run the job. Okay, another thing, the data's here, right? So you have data sets here. You have your file system here if you want that. It's all fairly accessible. Now let's go look at the REPL, okay? So I'm in Julia right now. I've already warmed everything up, right? I'm prepared, okay? But I want to show you the interactivity. So when I started this, I first went using Julia. I actually first, I first activated my project, right? So in my project, if I look at my project, I have my 2 dependencies. I look at my manifest, it's going to be massive, right? That's what you expect, okay? So that's pretty much par. And then let me just double check the code. Okay, that's what I need. All right, fine. So I'm in the right path. Things make sense. If I check the dependencies here, I see that those also are where they should be. Now the question is, having invoked earlier using this command using JuliaHub, I've already done that. I've also done JuliaHub.authenticate. I've already done that. In this case, I did it for internal.juliahub.com. Okay, so I got my token, everything's set up, and it's an environment variable running here, so I don't have to specify the token or worry about setting a payload for an API call. That's done behind the scenes for me. This is you get that for free. So when I have the JuliaHub package active, once I run this command, that's it. The token's there. You're good to go. Okay. And then finally, we get the command that I really care about, which is this one, the submit job. And as you know, I'm toggling up and down. There are two versions. Now, I went to this trouble to show where I'm sitting, right? I'm sitting at the root here of the project. So that way, this app bundle construction, this @dir, this macro is correct. Okay, so if I needed to go up or down a directory, I would have to specify that here. You need to be where do you need to be when using JuliaHub that app bundle? You need to be where your TOM will sit. Okay. You specify your entry point, and in this case, I specify sysimage equals true. So let's run this without the sysimage first, okay? And you get an idea of what this looks like. All right, I am super lucky today because everything's working fine. So now this is the response from the API call to JuliaHub, okay? And this is how I work. This is how we work in real life, what you're seeing. The UI is great, but yeah, when you're in a hurry, this is what you do. So you see how it created this app bundle.tar, the tarball? That's what it's doing, right? So it wraps it all up, shoots it off to Julia. It synthesizes its own code.jl and kind of presents a standard. It takes what we have and standardizes it for the API to make it easily digestible. These are the things we specify in the job image to, two CPUs, no GPU, single threaded, blah, blah, blah. Okay, great. Now let's look at what happened here. So I could click here. I'm in internal. All right. So if you see this internal.com, click on let's click on active jobs, or it's already probably already complete. Yeah, it is already complete. So I click on this, right? This is an example of a job that's been completed. Note that there's able to rerun and reproduce jobs. Okay, these are sitting right there for free. This is really nice for diagnostics. But this specifies the input and output. Remember that I had the JuliaHub API. It created the code.jl and appbundle.tar, right? These were created. So now I'm running from those. Let's see here. And then the output files as well. It specifies some output files. You'll see these in the logs, like this stuff will be specified in the logs from the job, which I'm about to show you right now. See, I click logs. And look at this. It's checking if Sysimage is available. No, I didn't specify it, so it doesn't look for it. Activates the project, and it runs in, I don't know, guess you could say, just under a minute. Okay, or 40 seconds or so, something like that. Yeah, 40-ish seconds. And that's without the Sysimage active, right? So you see here, prime count computes, this many seconds, very slow. I'm sorry, excuse me. This many seconds was very quick, and the number of primes counted up to 10 million. Wonderful. So this is the basic job interface. You have metrics as well, where you can, for just in this case, the time period was so the granularity is too narrow. I could expand it, right, to get some metrics of utilization with respect to CPU. So utilization of what? CPU and memory. Okay, so that would show here as like a line graph. Again, very handy to determine when you're like profiling code, especially. Big hint, my experience, when things are slow, it's IO. Like 90. If you can solve your IO issues, that's number one. Then the next one is type instability. Just freebie there, like either IO or type instability. People basically IO is not batching stuff, and type instability. You'll notice you'll just have these unbounded. When you're doing profiling, this like unbounded nesting of recursions. So just heads up from there. Okay, so now let's run it with the system image service active. Okay. Oops, I can just do this here. Let's type it in. All right, now I submitted the system image, and I'm gonna go to jobs, and now let's see, it's gonna show Okay. Ah, yeah, I already created this image, so I would have to clear that up. See this clear Sysimage cache? I actually already ran this, so it's using a prior Sysimage. Let me clear that. But in the meantime, what I'll do is I'll just show you the logs. You'll see how quickly it ran, right? Check if it's available. Sysimage found, right? So 39:15, it finished in, okay, this time it finished 14 seconds. All right, it works. And this doesn't scale because again, the overhead, it really is 2 seconds or 3 seconds, right? If you include the overhead, the other one has another 20 or 30 seconds of dependency loading. So it's actually a huge improvement, but with respect to scale, it doesn't really show off because of the baked in overhead. So you see how it works, right? Now, if I wanted to manage this, actually, maybe let's try something right now. So I'm going to go back to the Sysimage, to this job. I'm going to clear the Sysimage cache. Okay, so now it's invalidated Sysimage. Now, what should happen, and this is where I'm going to kind of stretch myself on this presentation. I'm going to submit a new job, and I should see, that's it. Yes, good. I'm building the Sysimage. So the first time you do it, you build a new Sysimage. Okay, this takes some time. Why? Because it's doing all the pre-compilation work. How does this really work behind the scenes? I'll tell you. When I build that Sysimage, it will be stored in the depot in JuliaHub. Okay? That's what's going on behind the scenes. So the first time when I toggle Sysimage equals true, and if the selector, remember the Sysimage selector, has never seen that toml before and everything else is good, no errors, no exceptions, it's going to build a Sysimage for me. That Sysimage will sit in my depot on JuliaHub for that user. So in the future, when the Sysimage selector, which is activated, every single job. Let's look at this. Every single job, let's click on any random job. Check a Sysimage. It's the first thing you do. The first thing JuliaHub does is check for a Sysimage. So when you think about payoff, like that's a no-brainer right there. Right? So use your Sysimage as well. To use your Sysimage as well, you have to use packages properly. If you use packages properly, right, and you use the Sysimage as well, and if you need to, you add private registries, you're in a really good shape for performance on JuliaHub. And then, like I said, we can converge back to those high tolerance or low tolerance things like Fortran, right? When we're doing a migration or you're just building something new. So let's look at the Sysimage build. Let's see what that entails. So it doesn't find it. Okay. Oh, this one did, I guess, but it's still. I guess. Oh, sorry. It finds itself. Okay, I should put that back. It finds itself, so this doesn't really mean anything. The way you know it's a Sysimage is that all these dependencies are being pulled in. Look at this. All this work is being done, right? 31 dependencies, precompiled 23 seconds. Well, that's your payoff right there. Okay. If you want to make it really simple, that's your payoff. So, and then compiling incremental system image, that's what it's doing. And then you go to package compiler to look at how like the system images actually associate. And then when you do it the first time, you see it's still running. Once that's done, you notice this is the actual job. So when I create a new sysimage, it does a sysimage build, and then it runs the job. They're sequenced. So I don't just submit a sysimage and like the job. No. This has to be done. The sysimage, the .so file, which is what it is, has to go to the depot and sit there. When that's ready, then the job is run. So presumably, we should see the payoff from the first time, except this job is in a queue, right? So this job, the actual compute job, is in the queue until the system is ready. So what does that mean? Well, I mean, you know what that means, but what that means is practically is whenever you have changes to things that you want to pre-compile, and obviously you have the correct architecture, and you have things in packages, and your packages are in the correct registry, and you have that managed properly, you need to run it once, and the first run will be slow because the sysimage has to be built again. Okay, so give yourself time. So the idea is, well, why are you telling me this? Well, real life. We may have a bunch of schedule changes. So let's schedule them for when the servers are down, right? I need to update the sysimages. Okay, well, you're not going to do that at 1 in the afternoon on a workday. You're going to do that when you can. So these are practical considerations to make, is when do you want to do these updates? So that's something of which you need to be mindful, is like this building a Sysimage can take some time, and it could take minutes for bigger ones, quite some time. So just be mindful of that. And but the good news is that you don't have to worry about it once it's done. It's also possible as an admin, if you notice, like when I go to a job and I have to clear a specific, let's say I want to clear a specific, you can do this via API. You can sniff. I'm not going to do it right now, but I can go developer mode. You can actually do a post request through the job ID and clear Sysimages that way via API. Or as an admin, you can just, if you're an admin user, you can just wipe all the Sysimages for your group. So you do have the ability to say, okay, guys, these are stale. I don't want to manually deal with them. Send the admin in, and he or she will just clear out the Sysimages for your group. Okay, let's look at this. So let's just look at this logs here. These are kind of fun. So you see all these dependencies. This is a manifest, right? Remember, it was just 2 packages, the project tunnel, but this is everything in the manifest. And let's see if we can find, yeah, here we go. Here's the bundle. Yeah, that's it right there. So this gets bundled. This is your .so. Now, if you look at the package compiler.jl documentation, this is it. This is what we're getting, and this is what's going into the depot, and this is what's being selected from the manifest. So now I think I have gone through fairly intricate evaluation of how this works and how it works with JuliaHub, and it's awesome. Like, it's legitimately an awesome feature. I would use it. I would design, and I would make sure that if I'm using Julia, if I'm working with Julia and JuliaHub, and I need performance, and I don't have Donald Knuth or a team of Knuths, I would make sure that my application is such that my costly dependencies and costly computes are in fact in packages and not sitting in code or modules, right? They're not just sitting as a module, that they're actually a registered package. That's a very big distinction, because I've had people use modules and they try to manually precompile stuff, which is okay, but then it comes apart with the Sysimage service. So make sure to use packages. Make sure to push. Actually, I even have a conclusion slide, so let's just use that rather than me. Slideshow. So make sure to get the power of the Sysimage service, use packages. Okay, you cannot use, don't be depending on modules or things like that. You want to use packages. Be mindful of the version used in Julia itself, because that is part of the manifest. And you can work with this with the UI or the REPL in using JuliaHub.jl. And the cache management is very straightforward. You can use a post request with the job ID. You can have an admin wipe them out, or users can do it individually. So with that, I think we're done. I'm just going to stop sharing for a second. There are some questions. I'm going to wait because I have some issue with my inbound audio. I don't know if that got fixed, but if there are any questions, please let them surface in the chat and we can talk some more. All right, well, that wraps it up. I mean, I think this was pretty clear presentation. The topic was not super complicated, but it was meant to bring a broad audience to a consensus with how to develop your application, how to or structure your applications so we have high performance here, and introduce a system as service. I hope that it's been helpful, and be in touch if you have any questions. All right, thank you so much. This is Phil Burns from JuliaHub, Sales Engineer. Signing off.